Okay, it's April 9th. It's the day after I did the deflection test. I have not obviously put any epoxy in here yet, but that's coming. I'm doing the vibration testing now. I redid my software a little bit, made it a little more user-friendly. I have noticed already, just doing a couple of tests here, and I'm just going to use a wood block and drop it off of here repeatedly. It's the best setup I can do by myself. I have noticed that if I put the sensor on the end of the table, anywhere on the end, it could be that corner, this corner, on the sides, but lesser on the sides, but mostly on either end, I get less vibration. So, for example, if I drop this wooden block here on this corner, see how long we vibrate. We didn't pick up very much. We got some spikes, but let me run it again with the sensor underneath the table. Okay, so I moved the sensor from here. It's mounted up underneath there now. It just sticks on with magnets, by the way, in case anybody wanted to know. So now if I drop the wooden block again, I get a different vibration reading. About the same height again. And I can actually hear a difference in the vibration. Now I have the sensor almost in the middle of the table. It's a little off center. Again, it's balanced on the single 1, 2, 3 block under there. I drop it again, I get even a slightly different pickup. So I get less. I get the initial impact, and that's kind of it. So I'm going to keep the sensor out as close to the end of the table as I can, but underneath it on this steel plate, which will be the top eventually. And that's where I'm going to do my testing at. Just thought I'd mention that sensor location is really important. Okay, the sensor's moved out towards the end of the table now. And we're going to do some testing. So here we go. It's much more long and drawn out. It's probably about 3 to 4 seconds of vibration. Yeah, it's about 4 seconds of vibration. I'll have to break the graph down and really look at it, but close to 4. So I'm going to do just a few more on the different corners, and I'm just going to save that data, and then after I epoxy it, I'm going to do the exact same test and see what kind of vibration I get. Well, just for fun. It doesn't really seem to matter which corner I hit. That was kind of a bad drop, but I end up getting about the same amount of vibration, even though the sensor's on the far end of the table over here. If I hit it over here, or over here, or over there, I get about the same length of vibration time. So I've done this corner, I'll do this one. Still 4.5 seconds. About the same. And just for the hell of it, let's do one in the middle. Not much. Yeah, not much. Probably because I have it suspended in the middle underneath a block, so right in that area, it's probably not going to vibrate much. But there you go, guys. Now I'm anxious to see what happens when it's filled with epoxy. Here's just a quick screenshot of the data that I captured in Excel. I'll try to just attach this as a photo when I post this on the web. But you know, these are my first couple drops. I got one little kind of a wild one there. I don't know if I dropped it different or what. And then this one was a bad drop. This is when I was doing the corners. But so this is I did several repeat tests. So working backwards, this is where I dropped it twice in the middle, and then I dropped it on each corner. This is the first corner I dropped it on, which was bad. So the actual vibration data I'm going to want to compare is between this point and the beginning. And I know you can't tell a whole lot here. This is just a numeric value that the sensor gives me. And really what I'm interested in is the time and not so much the amplitude. I mean, you know, again, I'm not a vibration expert, so I don't know exactly how to collect the data. I don't know exactly what data I need to collect, but I can tell that those all vibrated at about the same length of time. And I'm going to take this data, save it, and then after I've epoxied it, I'm going to repeat the test, and I'm going to lay one graph over the other and see, what I've got. I'm almost positive now that I've done some testing on the other piece that I'm going to see just little blips and almost nothing else. So anyway, that's the data I recorded, and can't wait to compare this to the epoxy stuff. Okay, I'm back. Table's been cast. It's had 72 hours of cure time. Ready to do some vibration testing once more now that it's cast. I've noticed that my surface plate is vibrating a little bit. I can pick up pretty minor vibrations on it. I just tap it with my hand here. I mean, it's the impact, but it's there. So I'm going to drop the wooden block on it again and see what we get. Hold on, let me see if I can adjust that so it doesn't glare as bad. That looks better. Okay, so first drop. And again. And then I'm just going to do a couple of drops on the actual granite table. Yeah, the table itself is actually vibrating, so I'll have to try and eliminate that vibration coming in there. I'll take the table off probably and do some testing on just the granite plate and eliminate that. But we're not seeing the long drawn out vibration like we did last time, so I'm pretty confident that we're going to have just little blips of vibration data. The only thing I'm really picking up is the actual granite plate, and maybe some on the rack here. Yeah, we're picking up a little bit from the rack, but anyway, we'll crunch the numbers, we'll see what we got. All right, this is the post-cast vibration data. There's just not much to show here. We got a blip where I struck it once, another blip, I struck it pretty hard there, and another blip there. That's it. There's nothing, there's no vibrating up and down in between these 2 points, or there's no trail off like there is with the precast data. And that you can pretty clearly see I struck it, that pointer, I struck it here, and then it continued to vibrate and kind of trail off all the way over to here. I got 3318 milliseconds vibration time in this one, 3740 here, 3845 here, and I got one other one over here as well. But they're all about 3.5 to 4 seconds. 3777 here. But you can see how it trailed off. There's definitely some vibration data there. I'm not getting that in the postcast data. All I see is a strike. I struck it really hard here, and a strike here. There's no vibration in between. I really don't feel like I'm getting 100% vibration reduction just with the casting, but I just don't know how to validate, exactly what I've got here. As far as I can tell, I mean, it has reduced it 100% by the numbers, but I know in practice, in reality, it's probably not really 100%. But I can tell you, if you build a steel shelled machine and fill it with epoxy granite or epoxy gravel, polymer concrete, whatever you want to call it, you're going to get some really significant vibration reduction. So I think we can put that one to bed. Okay, I finished the post-cast, or pre-cast and post-cast vibration testing, and the bottom chart here is the precast vibration data that I collected. You can see pretty clearly, I struck it. That's the peaks, and then there was some vibrations that were detected down, until they kind of trailed off into nothing. The orange line up here, though, this is the postcast data, and you can see where I struck it. And then there's just, I think I got 4 to 6 pickups of change here, but it was just diminishing, probably diminishing sound waves actually. But really all I got was the strike, and then no vibration picked up after that. To get these to line up, I had to add a lot of zeros in here to shift the data over to make it line up with the original ones, but it was just to make the chart pretty. The values that I picked up, I added 4,000 to them just to offset the charts a little bit and make it a little easier to read, but this is the best I can do, and I guess from what I can tell, there's a pretty significant reduction in vibration, but I think probably what's going to happen is I've changed the frequency it vibrates. I know the natural frequency of it before I started was 459.7 hertz, so it's probably a lot lower now. So hopefully, you know, it's not in a frequency that the machine will run at when it's actually cutting something, or it might become harmonic and then it'll just vibrate worse. But from what I can tell so far, if you build a steel shelled machine or machine with steel in it and then cast epoxy around that steel, you're going to get a pretty significant drop in your vibrations. That's all I got.